the Technical Advisory Council of the Confidential Computing Consortium. We are a collaborative group that meets every other week to discuss how we can advance confidential computing. Every member is welcome. Every project meeting our criteria is welcome. And we look forward to everybody able to constructively join in the conversation here, whether you're a member or not. We also abide by the Linux Foundation's antitrust policy. You can read more about that at linuxfoundation.org/antitrust-policy. Today, we've got a couple of announcements about upcoming conferences, the annual chair election, and then we've got a couple of great tech talks set up for today. One's going to be on storage, and we'll introduce that when we get to it. Then we will switch to see if we can do a little bit of live work amongst us on some open questions with attestation terminology. And then we've got another good tech talk from Microsoft on their Open HCL project. And that should probably take us through the time we have allocated for today. Were there any other agenda items that people were expecting to see today?
Just a reminder that the CFP, for RSA North America close on Sunday, having been extended for a week. And if you're interested in putting something forward, please do so. The more confidential computing related talks submitted, the better chance we have of getting some in. And I'm very happy to help people if they would like a hand with that.
Okay, good reminder. We do not have any voting items today, so I'll skip over doing a formal roll call. So quickly eyeballing, it looks like we might be at quorum if we needed it. Like I said at the outset, whether or not you're a member or a regular participant, everybody's welcome to join in here. So if you haven't introduced yourself to the community before, feel free to pop off of mute. Let us know how you like to be addressed, where you're joining from, and in particular, what it is about confidential computing that interests you.
I guess I'm happy to go.
Please.
Hi, everyone. I'm Jacob. I'm calling in from London. I'm with Entrepreneur First, startup founder, currently searching for what's next. Specifically interested mostly in open source silicon and active in the tiny tape-out community. But I think as AI systems get more powerful and advanced, confidential computing is going to be ever more important. So mostly here to observe and to learn from you all.
Great. Well, thanks for joining. We often have participation from the RISC-V community, so I don't know if that intercepts with your interest in open source silicon, but that is a regular topic for us as well.
Nice.
Anybody else who would like to introduce themselves? All right. Well, if later you would like to introduce yourself, just feel free to do so. We're pretty casual here. All right. As a reminder of what we covered last time, we also had a pair of tech talks last meeting, both fairly deep ones. The first was on being able to attach security policies along with your workload. So that's a pretty interesting one to take a look at, as well as the second one, which is more focused on how we can formally analyze the TEEs. Both of those are split out into the Tech Talk playlist that we have on YouTube. So thanks to Rian for continuing to curate that list. And then we also got a sort of call to action from Ab over in the repositioning working group. There's a lot of space for TAC member involvement there to make sure that we are helping to describe the kind of use cases that we think make confidential computing interesting. Two of the leading areas are, of course, confidential AI and secure software supply chain. And then we did have a little bit of time to talk about the attestation terminology, and that's something that we will return to again today. Moving into announcements, do we have Sal on? I think so.
Yep, I was just responding to a message. So, KubeCon, if you have not seen the announcements from the outreach yesterday, I'll encourage you to check that recording. But as of right now, we have pretty much every boothing session that we need covered for KubeCon, except Friday morning still, which is a light day. So if anyone has availability, let me know. I'm going to throw a link in the chat that lets you know anything about swag, anything else that you'd like to add to it. But I think we are pretty much good to go, and you should be getting an email from me the end of today with final updates.
Great. So if you haven't been to KubeCon before, it's a huge event. Floor space is definitely at a premium. So if you have something appropriate for the booth for Friday, please feel free to reach out to Sal. And is there more to discuss on this one as well?
I think we are good to go there. As of this week, we have pretty much all the sessions we need. We're actually covered.
Okay, great. And then, would you like to speak to this?
That is my cue. So I need to announce that we're shortly going to have the Technical Advisory Group Committee elections for the new chair. Thank you, Dan, for the excellent work that you've been doing this year and driving the work of the TAC. So we call for nominees for people that's actively involved in the process and the work of the TAC to either self-nominate or get themselves nominated. So the email will go out in November asking for candidates, or sorry, in October we'll send out the email asking for candidates, and the voting will take place in November, and all Premier members have the opportunity to vote for these candidates. And I'll send more detail on the TAC mailing list, and reach out if you have questions.
We should add that you do not need to be a Premier member to stand.
Absolutely.
Yeah.
And Dan, you are absolutely welcome to do it another round. You can stand again. I would not object.
Neither would I.
But we do encourage everybody to participate in whichever ways that they can, ways that you can contribute. You're more than welcome to put your name in the hat there. We're all about peaceful transition of power. So get a new leader, that is great.
Rian, I think if you could mute yourself, we're getting a lot of, sounds like a vacuum cleaner behind you. Not sure what it is.
Might be fan noise, but
he has many fans. He's a very popular guy.
Yes. Okay, and then I think this might be from last time. I'm not sure. This is probably the...
I reached out to brand repositioning, and they asked if we could just run this past the group. You did actually in the previous business, but this is the same topic. Please share your use cases.
Great. So I will drop this into chat. Okay, and we are into the first tech talk. So I think I see Chandra on the line here. Chandra reached out after, I'm not sure if it was in any way associated with the summit, but it was around August, reaching out to talk about maybe intersections with what the storage working group in TCG is involved with. And Chandra also contributes to the TCG DICE working group, DMTF, and I think some other standards organizations. So we're happy to have Chandra on the call with us today. Chandra, would you like to take over presentation here?
Yeah, so let me start sharing my screen. Is the presentation visible?
Yes.
Okay.
Your whole desktop is. There we go.
Okay. Oh, you know what? It switched. It switched. Give me 1 second. Let me readjust. How about now? Is the presentation visible?
Yep. And
Yep.
just a presentation.
Sure. So a little bit intro about myself, right? I used to be at Dell Technologies for a long time, and I worked on, as Dan mentioned, worked on various different technologies at the intersection of security and storage. And I was part of the TCG as a co-chair of the storage work group in TCG, DICE work group, DMTF, SPDM, attestation technologies and things like that. And confidential compute is a kind of a natural fit of a technology where all of these things come together. And one of the problem statements we have is in terms of the data storage and the granularity of controls, right? We have access control mechanisms in data storage devices, but where it is, the granularity of it is what I'm going to talk about as a problem statement, and talk about some proposal of a solution. So with that, let me get to the presentation. So this is what I'm planning to cover, a little bit of overview, the context and the problem statement, data storage and how it can be used for computational compute, and how it is used in a typical enterprise deployments today. A little bit of a detour into working of an SCD, because I think, some people may already have the full context, some people may need the context. So apologize if it's too basic for you guys, but just wanted to make sure that we have the basis covered there. Then I'm going to talk a little bit about the proposal or the mapping mechanism that I have in mind, and give you guys the status of the different industry standards, recent industry standards from NVMe and from TCG, and some conclusion and probably next steps, if you will. So that's what I have planned. So going to the first one, essentially the right side is from the confidential compute, right? You guys might have seen it already. So we have data at rest encryption on the left side, which is using SCD, right? You have authentication mechanisms to access data on a drive, and data is stored encrypted, not easily accessible. You have, controls mechanism there. Data in transit, while data is being transported between compute entities, between peripheral devices and compute or memory, you can encrypt the data. You maintain confidentiality there, and of course the data in use or data being computed. That is what is this whole thing is all about, right? This whole consortium is all about that. So we have those mechanisms, right? So what is missing? What are we trying to do? So although from a confidential compute consortium perspective, the data at rest protection mechanism or the confidentiality is assumed to be solved, or at least it doesn't get into the granularity of the details. It says that, hey, use an SCD drive, which is self-encrypting drive, provision it with authentication keys, and you have confidentiality of your data. You don't have any loss of data. You have access control. That's an easy way to do it. But then the problem is, let me go here. So the typical provisioning mechanism, typical way the HCD drives are provisioned in the enterprise today, right? So you have a server platform. Let us say you have a server platform. So you have a server platform, drives, and you have key managers outside the server platform. The keys are used at a complete granularity of a drive, right? So you provision one authentication key for the entire drive. Or even if you are provisioning different encryption bands on a drive, let us say a drive can be fragmented into 100 encryption bands, right, or 20 encryption bands. You can provision 20 separate authentication keys, but those are statically provisioned. They are not dynamically provisioned, and you have the ranges are statically set. And again, it's a lot more complex to implement, and you have to key manage. Your key management gets way too complex, and all those other challenges exist, right? So just a brief overview of SCD is you have SCD. First it comes. Let me go to my next slide here. A little bit talk about SCD use cases and SCD overview, right? So SCD are self-encrypting drives. You have recording media. It can be NAND. It can be magnetic media recording. It can be any other recording technology on the physical drive. You have the drive electronics already managing the media encryption keys. It is self-generating media encryption keys, symmetric encryption, right? You use the same key to encrypt the data and to decrypt the data. That is generated by the drive using random number generator, some other entropy sources and things like that. And that is always happening. It is happening at line speed. You are always writing the data encrypted on the media. You're always reading the data after decrypting, from the media, you read the data from the host. That is always happening. That is typically, if you look at the enterprise ecosystem today, I would say almost 100% of the drives that are shipping today, they already do encryption on the media. They already do decryption on the readout. What is different about SCDs is the SCDs provide a additional layer of security wherein you are provisioning authentication keys, right? You at the beginning, out of the factory, authentication keys are not provisioned at all, so you can use it like any other regular drive. But when you provision the authentication key, you set it up, you take ownership of the drive, then you set up one key or few keys and say that, hey, at every power cycle or any other boundary condition, it could be a reset, it could be interface reset, it could be power cycle. Typically, the policy is to do it at a power cycle boundary. The media encryption key is not accessible to the drive electronics or not accessible to drive firmware, but it gets wrapped with the authentication key. So the host has to present the authentication key, quote unquote, unlock operation. Then the media encryption key is accessible. Then you can perform read and write. Otherwise, you cannot even perform read and write. Why is SCDs used? What's the use cases? Typically, in an enterprise system, in a data center, usually you don't have drives just walking away, but at least, if there is a mistake, if there's service action, somebody pulled out a drive to service it, to re-provision the platform. If the drive walks away, you are protected. Without the authentication key, you cannot read and write the data. If you have stored confidential data, you cannot get access to it, period. If the data center is going through decommissioning, right? If you're decommissioning equipment, whether you forget to erase or you did not do your summon pass erase or whatever reason, you still are protected because without the authentication key, you cannot have access to data. Therefore, you're protected. That's why SCDs are used, and also transport between data centers, the same use case. Yes, Dan.
This is pretty new to me, so I'm curious, does this generally apply to machines with physically attached storage, or does it also apply to machines using network attached storage or storage area networks?
Both SCDs are used in both topologies. Machines with storage and also external storage, cluster storage, it applies to everywhere. But typically, I'm mostly talking about machines with local storage attached.
Okay, thanks.
So you have this overview of the SCDs and the use cases, right? Now let me get to, maybe I mislabeled this. I'm still talking about a little bit of a problem statement here. Mislabeled the slide as solution. But where I'm going with this is the granularity of the control, right? So in the confidential compute world, we are talking about confidentiality of the data on a per virtual machine basis, for example, right? Or a per user basis, per container basis, per application basis, right? You have granularity of the control and access controls mechanism wherein the data belonging to one virtual machine is not accessible to data to a different virtual machine. That's the whole premise of the confidential compute. And here in this world with data storage devices, the similar mechanism exists, but the granularity at which the control mechanism exists today and typically deployed today doesn't really map well to what we are trying to do in the confidential compute, right? So either in the most of the enterprise provisioning that I'm aware of, right? Take your big financial institutions, brokerage houses, banks, healthcare companies, government agencies. You think about them. You have a one key authentication key used for all the drives in the system, or you have one key per drive, but not much more granular than that, right? That is your typical TCG Opal implementations and things like that, right? So where I'm going with the newly introduced specifications. So this year, 2024, both the NVMe work group, which is its own industry standard organization, they have upgraded their family of specifications. They added support for key per IO, right? So key per IO is one key per IO. So on a per input-output operation basis, you can use a key tag and say that, hey, drive, use a key tag to associated with a media encryption key to encrypt the data on the write and to decrypt the data on the read. So you can do that with NVMe. I have the follow on later on. I have 2 or 3 slides later. I have the read write command details there. We can talk about it. And a TCG storage work group from the Trusted Computing Group, we released the Keeper IO SSC. SSC stands for Security Subsystem Class. So the Keeper IO was released again in conjunction with NVMe, right? We had liaison agreements. We worked together to some extent, and that is also enabling specifying a key tag on a per IO basis. So your dynamic range, dynamic LBA ranges, and you are able to specify a key and use that key to write the data while encrypting and use that key to read the data while you are decrypt the data while reading. Yes, Alex?
Yeah, I see NVMe there, and I've always just naively thought that NVMe was about IO performance. I didn't realize that it also had some important security enhancements. I'm wondering, when I think about support for NVMe today, should I assume that it already comes with per IO, or should I say per VM media encryption keys, or is this an enhancement that's being proposed for NVMe?
The NVMe already has published the specification, but I don't think you will see many commercial products yet with this capability. The spec work is done, spec work has happened. I don't think there is any commercial product, or if at all there are some products, they may be in a very limited environment, like with specific cloud service providers or something who can do custom stack. You may see some implementations there, but in a typical commercial product, I don't think there is anything with this capability yet.
Super helpful. So when I see NVMe, I should ask, hey, does this particular implementation support per key per IO or key per container, I guess is how I'm thinking about it. Okay, cool. Thank you very much.
No problem. So the main benefits, I kind of harped upon it already. So the media encryption, now the media encryption key can be specified by the host, say that, hey, use key number 1 to encrypt the data for virtual machine number 1, for example. So the access control and the granularity comes into play with this new specification. That's where most of the middle points here are where. So I'm hoping. Most of the middle
Can I ask a question?
Yeah. Please go ahead.
Finish what you're saying, and then I'll ask the question. Sorry.
Sorry. Go ahead, Offer.
Okay. I'm trying to understand one thing. The encryption and decryption is performed on the disk hardware. Does that mean that, as far as I understand, what about the data passing on the bus from the disk to the VM? Is that
so that
can I assume that it's passing in the clear?
Yes, today it is in the clear, but the PCIe SIG has already published ECMs, right? PCIe 6.0 already has it included the TDISP technology. In order to support the trusted execution environment, there was a ECM a while ago for TDISP, which uses or which banks on the SPDM protocol from DMTF to provision the link encryption keys, and you can encrypt the PCI link between the compute and the peripheral device, and that is not just limited to storage, right? It's any PCI device. It could be anything. So that technology exists. So it's now we got to, if you think about it from a connecting the dot point of view, you have the interface between the CPU and the memory, that is one encryption channel. Then you have the CPU and the PCIe subsystem, which could be CXL devices, which could be storage devices, network devices, GPUs, whatever. And that channel can be encrypted with TDISP. Again, I'm going on a detour. Sorry about it. My understanding is the CPU hardware, most of the mainstream CPU hardware may have the capability already, and there are some capabilities being looked at from a PCI peripheral devices as well. Hardware capability might exist, but the firmware and the infrastructure for key management and stuff like that, it is at various stages of consideration or development. I don't think there is anything commercial yet.
Yeah.
But very good point. We are talking about, we started with the 3 things, right? In use, in compute, and in transit. The in transit piece of the puzzle needs to be present. So I'm mostly talking about the granularity piece here, and the data. And then the other thing I want to talk about is from a erasure point of view. You can think of the erasure as feasible. Now I can granularly erase the data, whereas in a typical enterprise provisioning environment, when you have SCDs, you are erasing the entire drive, you're reprovisioning the entire drive, or you're reprovisioning the entire LBA ranges. You are not erasing at a very granular level, and this keep IO makes that happen. So let me go to next slide. This is kind of the visual of what I talked about, right? So if you have external key management servers connected on the management network, and this is your typical platform with local storage, right? Dan talked about external storage, so you can extend the concept to external storage as well. But I'm here putting it all in a quote unquote block diagram of a platform. So you have different virtual machines supported by a hypervisor. You have compute, you have memory, you have storage devices, and the secure session that Ofer referred to. You can have secure session here, depending on PCIe capability implementation. And if I blow up this NVMe storage device, and these are all, you can think of it as LBA ranges, storage ranges within the device, right? And again, I'm purposefully putting it all in different ranges, different locations. Like NVK1 associated with virtual machine, you can do the color coding mapping. And what I'm trying to illustrate is different LBA ranges of different extents can be specified with usage of specific key tags. And you can say, hey, for my user data associated with MEK or virtual machine one, it could be the virtual machine image or any data generated by the virtual machine, use media encryption key 1 to encrypt the data and to decrypt the data associated with it. So you can do that with this NVMe protocol, as well as with the Keeper IO. If the drive is implementing Keeper IO, you can do that. That is the illustration here. Just a visual of what I talked about in the previous slide as a solution. So you can do that. And the reason I'm just showing this here visually is the LBA ranges can be different and very dynamic, and it doesn't have to be in order. That's the point of the diagram here. And the way it works, the way the Keeper IO protocol, the Keeper IO SSC is defined is, you first take ownership of the drive, just like any other Opal drive, right? Today, commercially, we are very familiar with Opal drives. They are, largest shipping volume of any enterprise provisioned drives. You have Opal drives. You can provision them, and you can use them at a very granular, at a very coarse level, and you have a very similar mechanism. You take ownership of the drive, but then at the beginning you have to provision the keys, media encryption keys. You can provision 10, 15, 100, 200, whatever you can provision, and then you can associate it. There'll be a key tag associated with the media encryption keys. If the channel of the provisioning is encrypted, right? Between the host and the drive, the way to program a media encryption key is a secure session. You wrap the media encryption key with a first authentication key or a key encryption key, and that's how you program it. So again, you're preventing from the spoofing attack and things like that. And then once you are provisioned, you can continue to use any of the provisioned media encryption keys with the host IO, right? You can dynamically provision, you can dynamically add, you can dynamically clear the media encryption key from the key cache. All of that is possible with the Keeper IO spec, right? So that's about Keeper IO. That's really the newish. When I say new, the Keeper IO spec was released earlier this year, Q1 of 24. The NVMe spec update happened in around May, I would say, May, June of 24. Again, as I said, I don't know of any commercial products that do it, but the specification now allows for it. And the here's the real, the crux of the change in the ME spec to allow for it, right? So for they introduced a extension type field with a key tag value, and it can be associated with the read and write commands. And this is your typical use case. My other diagram is heavily influenced by this diagram. This is from the Keeper.io SSC usage Keeper.io SSC document, but this is mostly informational text talking about how to use it. Again, the vision we had is multi-tenancy, granular control, granular usage. That is why this specification was developed in the first place. So let me go to this slide. Again, this is talking about implementation inside of a drive. So you have key unique identifier, key tags, and then you have key tags associated with keys, right? So the keys are coming from the host, the media encryption key themselves. They are being inserted from the host, and there may be other entropy source that contribute to it inside the drive, but it is predominantly coming from the host. And once you provision a key, it gets assigned a key tag by the drive, and the key tag value is known to the host. And then from there on forward, the host will use that key tag to perform a read and write. Therefore, you can granularly clear it. You can say, hey, forget the key associated with key tag number 10, and that key is gone, and the key is gone, right? And as I said earlier, from a boundary condition, when typical policy is upon a power cycle, all the keys in the drive are forgotten. There is no persistent storage of the keys in the drive. Therefore, you have to reprovision the keys every time the drive goes through a power cycle to be used to use that drive. Yes, Alex.
Trying to follow this diagram very closely. This is super interesting. And I'm just not seeing on the host side a slot for the actual key. I see the UID and the tag, but I don't see the key itself. But you're saying that it's just not shown on the slide, but the actual media encryption key, the symmetric key, is provisioned from the host to the storage device using a secure channel. And you mentioned TIO or TDISP. Do I have that right?
That's correct. That's correct.
Cool. Just wanted to check that. Thank you.
Yeah, that's correct. So again, it's not shown because again, you think of it as two slightly separate operations. One is the provisioning operation when you provision the media encryption key, and then you are doing your high performance read write. You are just performing a read command, write command. You just send the key tag. You don't want to be always transmitting the media encryption key. Your read and write is high speed. Yes, Dan.
Yeah, just as far as check-in time here, I know that you have some ideas in mind about how we might be able to collaborate between the CCC and the TCG work. So maybe we can set that up in the next 5 minutes or so.
Yeah. Again, this is voice stack, right? I just took this diagram. This is either the last or the previous one slide. I'll wrap up quickly. So again, we have precedents of doing this very recently in the sense a little bit few years ago, where the IO stack had to be updated to use what are known as the PI fields, the protection information fields. Storage stack is very, very difficult to change, right? Because it's just the overhead of it, the high performance and demand is very difficult to change. But then we added changes across Linux and Windows and VMware to do PI. So it again requires some changes here in order to fully take advantage. And as I said earlier, the CSPs who maintain their own custom stack, they will be pioneers in adoption of the technology, whereas the general purpose Windows, general purpose Linux would be probably late adopters. Offer will just wait for a little bit. And this is really my final slide. So all I'm kind of summarizing is, you have granular controls now. The underlying specifications exist now, published in the NVMe specification. I have links all throughout the slides here for the NVMe and the Keeper IO specs. So you have NVMe spec that's published, Keeper IO spec that's published. It requires some changes into the IO stack. It enhances security, provides granular control of both the data, and also, and the last bullet is really my conjecture here. So you have all this right to be forgotten requirements, right, coming in from different government agencies and different geographies. If you can manage your ecosystem in a very intelligent manner, in the sense, hey, one key is associated with one user's data in my ecosystem, the moment you clear that key, it may be on 15 devices, 20 devices, whatever, then you have essentially achieved data erasure of that user's data, whether it is spread across however many devices. But again, all of that has to be worked out, right? The data sanitization is a much more complex problem because of the snapshotting, because of the spreading of the data, because of the logging, all of those things. It's much more of a complex problem, but I'm just hinting that these underlying technologies make it more feasible to do. With that, yeah, I'm open for questions. It's over around.
Yeah, just to, I assume when you're talking about the connection of this technology and Keeper IO to confidential computing, you suggest that we could have the keys for encryption associated with the software, specific software measurement, meaning that it's all of the diagrams are talking about VMs, but it's really not the VM, but a confidential VM or confidential container, whatever, with a specific software measurement should have, through the station-aware key management system, access to the key that it will pass to the disk.
That's correct. That's correct. That's correct. It is. So I just use the VM as an example, but you could think of it as application, think of it as user data, think of it as containers. The concept is extensible. Right. Yes, Ram.
Yeah. So the media encryption keys, if I understand this right, has been provisioned by the host, right? The CSP or the host is provisioning them, which means
Okay.
they have the host or the CSP has access to the media encryption keys. In the case of confidential computing environment, the CSP is not in the trust zone, right? If a confidential VM is being used, and the media encryption key is provisioned by the CSP, then that breaks the confidentiality requirements of the confidential virtual machine.
Got it. Got it.
How
No,
do you
it's a very
reconcile?
valid point. No, very, very valid point, valid concern. So the thing is, it is not. So let me go back to the diagram I had. So I showed this, right? I understand, but it doesn't have to be the key management server and the platform owner need not provision the media encryption key, right? You can generate a media encryption key from the virtual machine. You can provision it at the time of use to the drive, and then when your virtual machine needs to be deleted, you can just delete that key associated with that on the drive, and you don't have to give the ownership of the media encryption key to the platform owner or the CSP. It can be with the virtual machine or with the application. You have that ability. You can generate it, you can create a MEC, provision it, use it, make the drive, forget it, and then you can walk away. the CSP or the platform owner need not have visibility to the MEC top.
Okay. So in other words, the MEC will never get exposed to the CSP.
Yeah.
Thank you.
Alex?
One of the struggles that we've had with encryption of file system data is that compression algorithms are not particularly efficient when they're exposed to encrypted data. It seems that the only place that the data, as you've proposed this, would be in a clear state would be inside of the T or at the actual storage device level. Would and the platform then would be completely unable to access the data in the clear where compression might be effective. Is there anything in the spec that brings in the ability to compress the data while the data are in clear text, or is that orthogonal to this effort?
It is really orthogonal. The NVMe and the Keeper.io specs do not talk about compression at all. That's more of it gets into the realm of accelerators and data management. These technologies do not talk about it.
Got it. Thank you. This has been a great presentation. Thank you so much.
No problem.
Yeah, I agree. I don't think we've talked about storage much in the past. So when we think about what sort of things that we might be able to do together moving forward, did you have some initial ideas in mind?
Not at this time, Dan. Again, I'm just kind of, proposing the idea here. I'd be willing to listen to, folks if there is any more use cases, any collaboration we can do between TCG and here, coming up with use cases or white papers and things like that. At least at the beginning, right? And then if the ideas are firm enough, there may be more concrete things like a proof of concept or some open source type development effort that may be little further out. But that's what I'm looking for as a initial engagement model.
Yeah, so I think there's three things that came to mind for me. One is the idea of a use case oriented white paper sounds pretty interesting. So just this last couple of questions that we've had seems like they would be educational for the broader community. So if we put out sort of a reference pattern for how you would use Keeper.io with confidential computing, talking about the sort of key management infrastructure that you would want in order to keep actors outside of your TCB that you don't want in the TCB. Second thing would be sort of related on the key management side, which is we have a notion of sealing that came from I guess probably originally came from the TPM world. Sealing is available in SGX and maybe a couple of the other technologies for confidential computing, where that key is actually derived from software security state and measurements. So that's a second topic that we could have introduced into there. And the third thing has escaped me while I was talking, but I think there was a third idea that I had in mind. Oh, SPDM. So we have an implementation of SPDM and some associated tools as a CCC project, and I'm not sure where that intersects with the TCG work and the eventual inclusion of SPDM with these flows, but that's something else that we
can so the SPDM thing, as Ofer and we were talking, right? SPDM slightly sits on the transport side of it, right? You have the device authentication. You can do SPDM. You can provision the key disk session keys with SPDM. You can establish secure session, and then you transport the key disk keys in that secure session, and then now you have a PCIe secure session, but that's the boundary of SPDM, right? It kind of ends there. This is little bit separated from SPDM in that sense, right? So SPDM works for anything. It could be network, it could be in just like PCIe, right? It could be network, it is independent of the storage protocol. But yeah, we can definitely refer to that as a underlying secure communication and authentication or attestation infrastructure. In that space, it has a validity in that space.
Sounds good. Well, we could talk on this topic for quite a bit longer, but unfortunately we are out of time. What I will suggest is if this sounds interesting to anybody on the call, feel free to pick up the conversation on the mail list. What has historically worked well for getting white papers started is for somebody to just take ownership initially and create a first draft. And we often share those through globally accessible Google Docs. But I'm sure other mechanisms exist. So please do continue this on the mail list.
Sure,
And
thank you.
any other closing thoughts from you, Chandra?
No, nothing. Thank you. Thanks for the time here. Thanks for the very good questions.
Well, thanks for bringing this topic to us. Like I said, I don't think we've really been exploring storage enough here, and it seems like a pretty big area for us to have left untended. So I think we could do a lot here. Okay, so let's switch back to the agenda. We've got another tech talk coming up from Caroline, and I want to get to her before she needs to move on with her day. But to have a little bit of break between tech talks, we wanted to see if we could do a little bit more work on the attestation terminology. And I think we've got Mike back on the call. To keep this constrained.
Indeed, you do.
So to keep this constrained for today's talk, we took the workload term over to the attestation SIG, and Mike proposed some very quick text about the workload being the memory protected by the TEE. And so that, I think, is moving forward. The other topic was this question about what may a relying party wish to remove from their trust chain. And we had some mail list discussion going on that a couple weeks ago. We touched on this last week. But I don't think there's been more discussion on the mail list. So to set this up,
yeah, sorry.
Yeah, no, I'm gonna hand it to you in a sec here. In my mind, to set this up, the subtext for this was kind of related to these notions of, is the CSP in the boundary, or to what extent are they in the boundary? And a very specific example of that is whether or not they're operating the attestation verification service. But it became difficult for us to even try to enumerate the different actors that might be in a CSP without there being a sort of reference idea of what a CSP.
So just to recap something from the mailing list, which is that the mailing list, you asked the question, who might be in the TCB? And I pushed back on the phrase TCB being used in that case. And I'm much happier with trust chain or trust boundary or set of trust relationships. Because for me, TCB refers to the computing pieces rather than the organizational pieces or people, for instance. So when we say is the CSP in the TSB, that's a null question for me, I think. So I think, are there components which are owned by the CSP which might end up in your TCB, whether you want them there or not? And the answer to that is possibly. So an example of that would be UEFI/BIOS, which ends up in your confidential VM, for instance. That would be a component which is owned by the CSP, which ends up in your TCB. The only way of which means therefore that you have a trust relationship to your CSP. And what I posit, and the kind of the basis of the book, is that you want to be in a position where you can have as few parties in that trust relationships with as few parties as possible. And so you generally don't want your CSP in your set of trust relationships, because one of the reasons you're using confidential computing in many use cases, and not all of them, is that you don't want to have a trust relationship with your CSP, because you want to have a trust what's that domain, and I don't mean a TDX domain. I trust domain in terms of it's different definition, but you have a trust domain which you own, and which you have good ability to trust all the different pieces in it. So for instance, if that UEFI code was open source, and you had seen an audit of it, and it was part of the attestation measurement and verification, then you might be happy with that, and you can actually remove the CSP from that relationship, because you can bring it into your trust domain yourself. Does that make sense? So if we're going to talk about CSPs more broadly, again, we're talking about entities here, and an entity, if you say I don't trust my CSP, as you say, it's a very broad assertion to make. So what I'm saying is I don't trust the entity which is providing is operating the machines that I'm in charge of, because I want to isolate myself from those. And if you can, the CSP can prove that they're a completely different legal entity with no chance of being there's a particular phrase when you force someone to do something. Anyone remember that word? Starts with a C.
Compelled.
Yeah, well, there's another word as well.
Like corner them?
Compelled.
Yeah, but there's a technical term in computing which is, but yeah, so they basically can't compel so if you can have a legal separation, completely separate, and there's no way, for instance, for the part of the organization which runs the isolation piece to compel the part which runs the AVS piece to do things that you don't want, i.e. there can't be collaboration, then you're probably okay, because you're basically now talking about separate entities. But that's difficult, and particularly when you have government agencies which have the ability to compel entities to do things, that becomes even more difficult. So that's kind of my starting point, I think, for this. And I'll shut up for a moment and see what people have got to say to that.
I can start, and why I think that this discussion is important. I think that we need to put it in a certain scope. I'll explain what I mean by that. There could be the purist approach that everything needs to be exactly the most secure. Everything needs to be owned by in code that we totally trust, but it means that if we get to that purist approach, it will prevent a lot of the organizations from being able to adapt confidential computing and remote attestation, which is something that we want organizations that implement confidential computing to use, because without remote attestation, it's not really a confidential computing solution. What I mean by that is that I think that we could present the different layers, but we cannot say that it's, if someone reads at the end all of those definitions that we'll put, and will figure out that because they want to run something in a certain cloud service provider, and they don't get visibility into all of the code, or they're using the cloud service provider attestation-aware key management system, and they figure out that it's not secure enough, then we'll lose it all. We need to explain the different parties and to present what are the risks, but the customer gets to choose at the end of using an attestation aware key management system that is controlled by the CSP, for example.
So, Ofer, these are excellent points, and this is exactly the conversation that I want to be having. So let me respond, if I may, to some of the points you make there. So the first one is, yes, we need to be pragmatic, because if we're not pragmatic, this is not going to be taken up. I 100% agree. That said, I think it's equally important that we should strive for a position in the future which is as secure as possibly can be. And we should design for that. The next thing you said was it's about risk, and it is absolutely about risk, and we have to be able to explain those risks to people. Because it's when it comes down to it, what confidential computing allows you to do is to change your risk profile. And if we can't explain that, there's no point, right? And it may be that people are happy to take those risks and that other people aren't. And I would, one last thing, say is that we're already seeing some bodies, such as regulatory bodies within Germany, saying this is not good enough. I can't. We cannot accept this if you're using this. For instance, maybe for data sovereignty reasons. Maybe it's okay for some internal things, but it's not for others, which again is a risk calculation, right? So I agree. We need to be pragmatic. I'd prefer that there are attestation services being run which are not at the highest level of assurance at this stage than there not being any at all. But I want to have this discussion and say we need to get to this place so that people can understand, and we mustn't pretend that everything is perfect. There's, of course, a very difficult line here, because between our being techies and wanting to be as clear as possible and scaring off the sheep, as it were, right? I mean, I don't sheep in a bad way. I just mean scaring off the actual normal. That sounded really bad. But scaring off actual users of this, and we need to tread that line. And there's which is why yes, attestation verifications is hugely important, and we should be pushing it wherever possible. And now let's talk about how we get up to better and better places. Does that make sense?
Yeah.
Cool. I've got a couple of slides if it would be useful for people. Are you happy for me to share those briefly? These are slides I've given a number of situations down. Let's just see if I can make this work. Application window. Here we go. Right. So this is can people see this? Is the first question.
Yes.
Okay. So this is kind of how it's honest talk about this. These are the different entities we care about. We've got the tenant, CPU vendor, TE runtime vendor. Think something like Grameen or NARCs or something like that, which is basically running the stuff. And then you've got your CSP host owner down here. And we've got trust relationships. And the tenant needs to have a trust relationship with the CPU vendor and the TE runtime vendor. Fair enough. What they want to avoid, because the CSP is running it, is having a trust relationship to the CSP host owner in this context, which is trust that for isolation. And these are some of the pieces here, right? We have TE attestation, the CPU firmware, the TE instance and the host system. So TE attestation, this is kind of the AVS piece. This is before we had the words, right? I wrote this. Basically attests that the other bit is good. It basically gives you a transitive relationship from the tenant to the CPU firmware. And that allows you to have a transitive relationship to the TE instance. Now, of course, the CSP also has a trust in their host relationship to their host system, and this is all good. This is how you want it to be. There's no crossing of boundaries here. The tenant doesn't need to trust the CSP host owner because it doesn't trust the host system.
But there is something here, and the guys from the CSPs can add on it, and we talked about that. Even you trust the code that runs the CVM, and that's
What's
a code
CVM?
that is coming.
What's a CVM?
Confidential VM, let's say,
The
or the T.
UEFI stuff, the UEFI stuff, and you really shouldn't.
Yeah.
And this is one of the things that I talk about in these slides, right? Is that you don't want to be trusting that stuff, because as soon as you do, you have created this relationship here. So that's why you want open source BIOS or no BIOS at all, which is what we did in NARCs, so that you can have that as part of the attestation measurement and verification, and therefore you remove this trust relationship here.
Yes, but in reality, with the technologies that exist today, and we had the talk by someone from Google Cloud, that this code today exists, and we want it to be open, we want it to be reviewed, and we want to have those, what we call them sometimes, launch measurements that are coming from a specific instance in the CSP, and when they fix a bug. So yes, we want to get away from it, but that's the reality today.
Yeah, no, great. So this is where we want to be, but we're not there yet. So this is another, what are the risks? Are we happy with them? This is where we want to be. This is this picture here is the perfect case.
Okay, I got you.
And so the problem that we have is, if we, exactly. Those two cases are, we don't want to be trusting we don't want to have to trust the CSP either because it's running the AVS or because of whatever it's put into the TE itself. And that's why when we wrote NARCs, we didn't have that. We wrote our own mini kernel and our own hardware abstraction layer. We didn't take anything. We took bare metal. If you're interested, I can talk about it in a lot more detail.
Yeah, but
we used
I think
WebAssembly as the
it was SGX and not the.
No, it also did
confidential.
SEV. I also did SEV SMP, and we were ready to go to TDX. So yes,
but there is something there is a code that launches that CVM. You cannot really just rely on what you have in the CVM.
You can absolutely get a bare metal instance and ask for just a vCPU and some memory pages. So it is possible.
Okay.
It's not the way that usually these things are done. It is more complex, but it's also a lot more secure. And we failed at Profium because people weren't ready for this, right? And that's
it's not only the people.
Enough.
It's not only the people. I as far as I know, you cannot really get bare metal machines with technology in every cloud. It's much more complex.
Oh yeah, no, I agree. Let's talk about particular technologies another time. Very happy to discuss it, and if anyone wants to take up NARCs again, I'd be very happy. But because it's the perfect architecture, of course it is.
I hear great things about it. But as far as this conversation, I'm curious what sort of artifact or actionable progress we would like to make.
Well, can you go back to the slide that you had up, please?
Yeah.
And we should probably call this fairly soon, I think.
Yeah. But I do want to be able to move forward with this conversation.
Yeah. So the question is, should we have the CSP out of the trust boundary? And the answer is yes, we should, but could is very difficult at the moment. So I would love it if we could say as a as a group that this is what we would we'd like to aim for as a as an industry and as an ecosystem, because it's the most secure of the options, even if it's not yet available. So that's kind of where I am. Manu has a question, I see.
Well, actually, I want to second that. I think this is where we need to go. That's where the CCC needs to go. I agree, Ophir, that we're actually trying to get there. So maybe we're gonna fail, and and I hope not. But Mike, I'm very interested in actually continuing the conversations about NRX and how we could use NRX in what we are building in some way, or at least get your expertise. But I think as the CCC, we should set the bar to what is eventually technically possible and should be achievable, with a roadmap to get there. Understood. And in fact, we have that problem right now that we're running in the Azure cloud, and it's great because we get SGX, but we already are bumping into some of the limitations that because Microsoft does not let us do some of the things that we would like to do, have access to bare metal machines, for instance, that give us the SGX, full TDX control and things like that. So I think as a CCC, we should push the CSPs to actually go all the way there, even if it takes more time, it's more complicated, because some companies are trying to actually make it happen. Because if we get to that place, then we can have cryptographic chains of custody and cryptographic chains of authority, where I can explicitly delegate management of that specific cluster of machines to Alec, right? And Alec is a Microsoft employee, but it's irrelevant. I delegated authority to a specific individual, regardless of a whole group of anonymous people who could go and tamper with my stuff, right? I trust Alec. I delegated authority to him across domain with a cryptographic chain of verification. So that's my point. I second what Mike was saying, and I think we should push forward with this.
So
I think
here's
Alec is next. Oh,
sorry, let me just.
I feel Dan, I feel you trying to wrap this up, and I'm going to go with you. I think one of the things that we can do, well, I'll just say, I read Diona Glaze's post yesterday, and speaking, I mean, Manu's already outed me as a Microsoft Azure employee. So I'll say, speaking as a Microsoft Azure employee, with great admiration of the work that Diona's done to get signed UFI. That's really cool. And she's working hard to get it incorporated into IETF standards, which is even cooler. That work, I think, makes things more secure. It also brings an added burden on customers to sort of bring Google code and Google attestation evidence and endorsements into the TCB. So it seems like at every turn, when we try to make things more secure as cloud service providers, we're bringing more of our own code into the TCB, and it seems like it's a little bit of a paradox. One of the things that keeps me from being able to talk about it clearly is that we don't really have a good diagram that shows each of the pieces and the attestation evidence that goes into those. And the talk we heard today brings yet another piece in, which is a confidential storage device that could be attested and then trusted with clear text data. So I think having a diagram as the one Mike has sort of proposed, just with circles and letters in them, that identifies each piece and then talks about who provides it, the supply chain for providing that piece of hardware and the firmware on it, and then each of the pieces of attestation evidence associated with it, from the endorsement to reference value provider to attestation verification service. Have a full diagram of that for a meat and potatoes use case, like a confidential VM that includes the need for confidential networking, confidential storage, and confidential key provisioning would be huge. And I've been trying to find time to work on that since Nathaniel McCollum sort of made me aware of it in a tech talk a few months ago. Would love to follow on that effort. Sorry, didn't mean for this to be that long a comment.
Good comment, though. Drasko? Maybe going off of mute killed Zoom there. So
sorry for that.
Oh, yeah.
Just wanted to also mention, and there is a talk that we presented recently in Vienna on Open Source Summit, on the mini CCC Summit. It's that the problem that we were trying also to solve is a problem of multi-party computation. So not but it becomes even more problematic because when you have a multiple parties that do not have the access to the VM, because they cannot go into VM and inspect, the files will be visible to them, etc. So you must protect any access to the VM, but you must allow for the attestation somehow, and you must have also a TCB or the operating system or whatever HAL is needed to be put into this VM. And then what we, have been capable to achieve this only with bare metal machines. And we needed to build our own Linux kernel and create our own mini embedded Linux distribution with build root. And because we needed to put all the way we boot stuff, the UEFI, the root file system and stuff into measurements, and also, for example, assure that certain portions of RAM are always, let's say, TempFS or something else that will guarantee that they are in the RAM. That swap maybe will be off or not. It depends if the swap also keeps the encoded portions of RAM and so on. So there are modifications that you need to do also to the, let's say, Linux distribution that is running inside the VM, which you don't have available always with cloud providers. And I saw a Google's product called Confidential Spaces, for example, where they list all those practically measurements, how they needed to harden the image that goes into VM for the collaborative collaborative, let's say, AI or processing. So this is also one of the aspects that I wanted to mention, is a aspect not only when you have single party that can go inside the VM and do the attestation, but somehow a multi-party where nobody trusts nobody, but they need to attest somehow outside of the VM through an agent, get an attestation of what is happening inside.
Okay, thanks for that. Mike, 30 seconds, and then we got to move to...
Okay. So I'm just going to say, Jacob reminded me, it's coerced is the word. We do need to do this. I think it is complex. To Alex's point, yes, you're taking more code from other people, but if it's open source, that's fine. Anyway, so that's we can continue to have this conversation, and I think we should. Yes, thank you very much, Steve, for the time, Dan. I appreciate it.
Great. So maybe one last question to take to the mail list would be, if what we want to get to is a diagram like the one that you showed, or an A versus B diagram, kind of like up here, maybe we can at least set that as a goal so that we don't, so we're able to have some sort of material output from these conversations.
Speaking of open source, that was a great segue, Mike, to our next tech talk.
Okay, so these diagrams are in chapters 11 and 12 of my book. I'm happy to make them available under license if we want to do that, or to rewrite. It's there. The conversation's there. And it's not that I want people to buy the book. I just want people to be discussing the same thing and disagreeing with points, so that we don't go over and over stuff. That's all.
Okay.
Sorry.
All right, to the list then. All right, so Caroline has been extremely patient, but hopefully also enjoyed the conversations that we've been having leading up to this point. I have not yet had an opportunity to speak to Caroline or to learn about OpenHCL directly, but I understand that it was a topic at the mini summit or at the plumbers conference in the last week or two. So we're excited to hear about it here, and I will turn the show over to Caroline.
Thanks, Dan. And thank you for giving me the chance to present here today. You're right, we did present at Plumber, so if anyone attended that session, you might be hearing some of this content for the second time. But hopefully it's still interesting. Sharing my screen right now. Can you see the presentation? Perfect. So, hi everyone, my name is Caroline, and I am the Confidential Computing OS Platform PM at Microsoft. And today I wanted to talk about a very, very exciting project that we've been working on for a very long time, and it's called OpenHCL. And this is our new open source paravisor for confidential VMs. And I sometimes will say CVMs just because I'm very used to saying that. So if I say CVMs, I just mean confidential VMs. I think before we dive into specifics of OpenHCL, I wanted to ask here if people are familiar with the term paravisor, because I feel like when I look online, there's not too much information around what this is. And I don't think of it as a Microsoft term. I think of it as a generic term. It just so happens that I think Microsoft is the only company that's implemented one. Again, if anyone knows differently, please let me know. But yeah, does anyone know one or want to kind of put something out there?
It's not a Microsoft only term, although the Zen hypervisor project would say, I think that theirs is a paravisor, but you might disagree depending on your definition. So I think it's probably worth having.
Oh, that's great input. I mean, I can tell you what how I think about a paravisor, and I would love to hear your thoughts on if that meets their definition, and would love to hear more about them too.
Well, they're part of Citrix, or they were been around for 10, 15 years. So
yes, I mean like their paravisor implementation.
Yeah, sure. I can't remember the details. Anyway, carry
on. Well, basically, a paravisor implements the TEE enlightenments on behalf of the guest OS, so that the guest OS does not need to be fully inlined. It can run mostly on unmodified, or in theory, even completely unmodified. So this paravisor enables guest operating systems that are not fully inlined to run inside a CVM. And not fully inlined guests today basically includes legacy and future versions of Windows and legacy versions of Linux. And by legacy, I just mean like old versions of Linux that don't have the alignments. I don't know the specific like kernel versions, but I could put those in the chat later. A paravisor, by definition, must run at a higher privilege level. And this privilege separation is enforced by the confidential computing hardware platform itself. So on TDX, that's TD partitioning, and on SCV-SMP, it's the VMPLs. So I'll pause here. What do folks think?
When you say enlightenments, you're speaking specifically about instructions that a guest OS would expect the machine to support, like TDX hardware or SCV-SMP hardware, but that the hypervisor doesn't support. And so the paravisor has to intervene to do work so that the guest OS doesn't have to trust the hypervisor to do those confidential things. Is that a rough definition?
Exactly. Basically, traditional guest operating systems are used to interacting with the virtualization stack in a specific way where they like inherently trust it. And so in a confidential computing platform, that no longer is valid. So they need some alignment, some changes, some hardening, etc., to interact and basically like defend itself from things that are outside the TCP.
So paravisor supports para virtualization.
Sorry, I didn't understand the question.
So we have para-virtualization.
Mhm.
Paravisor is the one which supports this para-virtualization.
Yes. Or sorry, Dan, you went off mute. Were you gonna?
Do you know para-virtualization?
Yes, but I think sorry, I still don't understand the question.
So
So I think what he's saying is that a paravisor supports para-virtualization.
Yes, exactly.
Yes, and I think hopefully that can also become a little bit more clear once I show a diagram. But yes, certainly. In fact, we have like para-virtualized devices in running inside of the OpenHCL paravisor.
So there is this something called ultravisor, which is in on the IBM Z S390s, which does something similar. Earlier, you were asking whether you've heard of paravisor, right? There is something like there is something called ultravisor in the IBM land, on the IBM Z land.
Ultravisor?
Ultravisor, which
Okay,
which
awesome.
does something similar like what your paravisor is doing.
Thank you. That's great to know. Like I said, it was just to my knowledge of what I had seen was out there, but I'm glad to know there's other things like this.
Yeah,
Or
that's
maybe
been
that are really this.
yeah, that's implemented on S390s, and also it was used on Open Power.
Just one question I have on this topic. So you're saying that enables unchanged practically OS to run inside the guest. So what are the changes that we typically need to do? Because why is not this possible today? I think Linux, you can run it in practically unchanged. You need guest drivers or something, a couple of drivers that you need for the attestation, but there are no changes to kernel or even root FS or something like this.
Yes, so I'll go into a little bit of that detail in, I think, to hopefully answer that in the next few slides, so that's okay. So before I talk about OpenHCL, I'll talk about our first implementation of a paravisor that we had in Microsoft. And so basically what this diagram is meant to show is that for traditional VMs, we would usually have emulated devices and UEFI services running in the host. But when we implement the paravisor, we actually moved those emulated devices from the host to the guest paravisor. And this enabled confidential VMs to have a TPM device as well as secure boot. So you can see it's these two things here. Again, the fact that we have this privilege separation between the guest paravisor and the guest OS, and it's protected from the host is exactly kind of what allows this model to work. Something else is we began storing guest state in this new special file that we call the VMGS, the VM guest state file. And the VM can now store its secrets here, and they're inaccessible to the host in the case of a confidential VM because they're encrypted. So the host only ever interacts with an encrypted VHD. And the guest paravisor basically takes care of doing that on behalf of the guest. So the guest still will interact with UEFI services the way that it traditionally did. And the difference is it won't be emulated by the host. It'll run in the guest paravisor and it'll interact with this file. I think one of the questions was like, what other changes are required besides the drivers? I think to truly defend against like potential interrupt-based attacks, traditionally the APIC emulation is done by the hypervisor, but with a paravisor, that can help in actually doing some proxying for the interrupts. So when an interrupt is coming from the hypervisor to the guest VM, the guest paravisor can validate that before re-injecting it into the guest OS. And then the other kind of enlightenment is there are new exception types that a guest needs to be aware of when running on a confidential platform. these are actually hardware platform specific. So they have like different terms on like AMD and Intel, etc. So you need to be in line to know how to handle that special exception type. And if you have a guest pairwise, it can just take care of that on behalf of the guest. So the guest doesn't need to have those changes. Lastly, there's also remote attestation. Since that is kind of by definition part of what a confidential VM is, the guest would also need to do that. If it's a confidential VM, it would need to perform attestation. Whereas if you have a pairwise, that can also do that on behalf of the guest. The guest can still do it afterwards. There's no one or the other, but if the scenario requires it, the guest pairwise can do this. Hopefully that answers part of the question that was raised earlier.
I'm guessing so. Feel free to move along.
So yeah,
Okay.
maybe I just have a question here for the VTPM. Does it implement a virtualization of TPM here as well, or?
Yes. So it is a VTPM. I think there it's listed as TPM, but it's technically a VTPM implementation.
So it implements it. So in somehow it is similar also to Coconut project from SUSE, which does the implementation of VTPM through SVSMs.
Yes, and I actually have a slide on Coconut too.
Very interesting. Yes, thanks a lot. Yeah, great.
Yeah,
and also I'm reading that there are interactions with acceleration, accelerated IOs, so interaction with GPUs, etc. Is it implemented through the hypervisor also? Or? Maybe I'm running ahead.
No worries. I didn't understand the question. Like for the confidential GPU products we have in Azure, you're asking what the role of the pairwise is?
No, actually, I read in the on the blog post of the Microsoft here that it also implements a paravirtualized I/O model.
Yes. I'll get to that.
Okay, so
this
I'm
is
running.
This is the old pairwise. The new OpenATL pairwise has that new functionality, which is really cool.
Okay, great.
So
thanks.
OpenATL is basically the next generation pairwise, which is, I'd like to clarify, it's going to be open source very, very, very soon. It's not today, but I'll be very excited to share the repo and all that with everyone here once it is. Again, very, very soon. I just can't say a specific date. But in addition to what the old pairwise had, it has more diagnostic capabilities. And sorry, that both is a typo there, but that helps debug CVMs, which is like really, really useful because debugging CVMs in general is a hard area. So this is something that, because it's inside the TCP of the CVM, it can basically, again, just protect. So any information that is going to go out to just externally for debugging purposes, the pairwise can in theory protect it in whatever way it needs to, whether that's encryption or something else. Device simulation is something we had before, but now we have a larger set of simulated devices. And these are exposed via standard device interfaces. And then I think what you were asking about in the blog post is device translation support. So basically what we have is we are able to assign, for example, an NVMe device directly to the VM, and it's assigned to the pairwise, and then the pairwise exposes this to the guest OS as paravirtualized SCSI, so as a paravirtualized storage device, as opposed to like a directly assigned device. And that really has allowed us to meet really great, I would say, targets for our storage and our networking capacities on like the very, very new Azure SKUs. And lastly, this supports virtual trust levels, which is a Hyper-V term for like privilege separation, both on x86-64 and on ARM. It also supports AMD, CVSMP, and TDX. And as far as the guest, it supports legacy BIOS, the Hyper-V virtual firmware, and also Linux Direct Boot. These are statements, again, about what the code itself supports, not about what is necessarily running in production today in Azure, but this is what the code is capable of today. So if we look at just really quickly the old diagram we had shown, we had the UEFI services and the emulated devices. And let's say these things are the core pairvisor support. So in this new OpenHCL, these three are kind of like one box right here, the pairvisor support. And again, we have like more emulated devices. And we actually moved the virtual devices to be inside the OpenHCL. So these are actually like the pair virtualized devices. So if we go to like the very beginning, like how traditionally things were done, these were running in the host, both emulated and pair virtualized. With the first round of pairvisor, we moved emulated devices, and then we went all the way with OpenHCL and also moved a set of pair virtualized devices. As far as the components of OpenHCL, the two main ones are basically a VMM that is running mostly in user mode and implements a bunch of processes, and that runs on top of a very, very small customized Linux kernel that we basically built to, again, just be very light and have only the things that were needed to support the VMM running on top of it. And one key thing to mention is that the VMM itself is written in Rust as part of just our effort to have memory safety as much as we could. Any questions here? If not, a few other things about OpenHCL. Certainly, we're tracking the upstream kernel, and we really aim to upstream all the kernel patches or have a path to eventually do so. Again, these are the patches that are in that OpenHCL Linux kernel. We try to do as much as possible in user mode. Like I said, the VMM itself is in user mode. We have some device drivers in kernel mode, but the majority of them are in user mode. Not only do we use Rust, we try to use safe idiomatic Rust as much as we can. We also use async Rust as much as we can for performance reasons. And we try to keep the VMM code OS agnostic. So the VMM, like I said, runs on top of a Linux kernel, but we try to always keep that OS agnostic, so the VMM could run in other environments, not just Linux. And the OpenHCL is Linux today, but that way that VMM can be used for other scenarios in the future. And I think this is actually my last slide. How is OpenHCL different than Coconut SVSM? Well, it is just completely different in that it solves a different problem. So it's not at all something that is a competition or like a competing product, because Coconut is an SVSM, whereas the OpenHCL is a pairvisor, and an SVSM aims to provide services to confidential VMs that are fully enlightened, whereas the pairvisor aims to provide services, and maybe one service in common that was pointed out is like the VTPM, certainly, but to guests that are not fully enlightened. So the way things work today, if you're one or the other, you can only get this functionality from either an SVSM or a pairvisor, and there is some shared functionality, but it's targeting like different types of guests. And that was my last slide. So questions, thoughts, any feedback would be appreciated too.
Great. Yeah, I know I was holding back. I didn't know how many slides you had. This last slide, though, does beg a couple questions for me. One, I think somebody asserted to me over the last few days that one of the things that you would do with OpenHCL is potentially run it within Coconut. So Coconut would be sort of a a housing for OpenHCL. Is that a correct interpretation or possibility?
I wouldn't say we have a specific way in which they're going to intersect. I would say we are very, very much interested in them intersecting. Intersecting, sorry. Yeah, and we've been collaborating with them and actually contributing to Coconut, or like some folks in Microsoft as well, because we think it's so valuable, and we definitely want to see an interception point in the future. We just don't know exactly when in the future and what it would look like.
Mm-hmm. Like Mike is next.
Yeah, so great to see this excellent work from our friends and colleagues at Microsoft. Thank you very much. So I think the thing that I like about this is the awareness that not everything is going to be enlightened, and I think there's a variety of ways in which things may not be enlightened. And when we start talking about lift and shift, is this a useful way to think about that? Because even if things are using more recent kernels, it may be that they don't know what to do with attestation, for instance. And so I think there's a really interesting set of useful discussions to have there. So I'm really, really keen. I would remind you that the CCC is always happy to accept interesting and useful confidential computing related open source projects. Whether this is appropriate for that, I don't know, but it's great to see it. Really like it, and please come back and tell us more about it on another occasion. Really, really liked it. Thank you.
Thank you so much. I really appreciate that. And yes, we're definitely very interested in the CCC support. So we can talk about that another time. But for today, I just wanted to tell you about what this is. And hopefully when we talk about the latter, we'll already be open source. So, and to your point on lift and shift, that is exactly why we started this investment like almost a decade ago, because, we saw the value of confidential computing, and we really wanted to enable lift and shift of as big of an array of operating systems as possible, and customers using like a very old OS that might not have enlightenments, but certainly wants the security benefits of confidential VMs can hopefully benefit from this. And one thing I would like to say actually is the fact that let me go here. The fact that in this diagram, oh no, sorry. Do I not have one? Yeah, okay, so ignore the old pairvisor. Focusing on the OpenHCL pairvisor, the fact that this runs on Microsoft Hypervisor and Azure Host OS is very much a point-in-time statement. The way we've designed OpenHCL is actually meant to be OS agnostic. That's actually one of the principles we listed. And we would very much be interested in seeing this be adopted by other virtualization stacks, other hypervisors. It's just not something that is like fully supported today, but hopefully now that it's open source, we can contribute with other people who have really great expertise and make that happen in the future. But yeah, like just again, want to clarify, that's just a point in time statement. Like our whole goal and the way we've designed this is to be OS agnostic and platform agnostic.
And so a potential consequence of that could be that if your host operating system is Linux and you want to run an unenlightened Windows guest, this could in the future maybe help fill that gap.
100%. That is the aspiration.
Very cool.
Neat.
Drasko, I see you look like you're next in the queue here.
Yes, thanks. So thanks for this great work. It looks extremely useful, and especially connected to what I was telling before, that we were practically forced to run our solutions on bare metal machines. And one of the things that we struggled with a lot is virtual TPM. This is why my question was there. And Coconut has only recently added completely this support. However, this seems as a very interesting approach that is wider than what Coconut is addressing. I have a few questions. One is, I think you already maybe touched on this, but this hypervisor, so the availability of running it in QEMU, so this is what we are using as a hypervisor. Then the question about of applicability of this on confidential containers as well, in kata containers, and I don't know, they probably have their own kernel, but I think maybe this can be beneficial as well. And then finally, if you can um, give a little bit more details on those privilege levels and compare OpenHCL with Coconut when it comes to those privilege levels in which they are run. So those are my three questions here.
Sure. I think the I'm trying to think what order to tackle them in. Maybe for the privilege level one, the last question you said. So I believe that Coconut also runs, and actually I'm gonna go here. I believe that Coconut also runs in VMPL 0 on SCVSMP, but I'm actually not sure because there's 4 privilege levels, and as long as it's one higher than the guest, I think that's sufficient to keep the security promise of both an SVSM and a pairvisor. So for our implementation, we did VMPL 0. I can certainly follow up and find out if Coconut is also VMPL 0, but I think if your question was, do Coconut and OpenHCL use the same privilege levels, like the same boundary between privilege levels, it is. It's VMPL.
Yeah.
Or did I misunderstand your question?
Yes, this is what I wanted, because I was reading quickly the slide and just wanted to understand, especially we are using SCVSMP, so VMPL 0 would be the place I would also put it in. So
yeah, because it's the highest.
Yeah.
And that leaves the other two open for possibilities in the future. For example, for Windows Guest in Azure, we actually do use one of those other VMPLs for guest VSM, so to run the secure mode, if the guest wants that functionality. And VMPL 4 is, of course, the guest OS, because that's the lowest privilege level. I'm sorry, I blanked on your other two questions.
About QEMU and kata intersections.
Yes. Okay. Thank you, Dan. I think the answer for QEMU is absolutely the same as for anything. Like, without sounding like cliche, like the sky is the limit. Like, we really mean it to be OS agnostic and capable of running in different platforms. So I see no reason why QEMU would also be on the roadmap in the future. For containers, that is, I think, something we've talked about internally a little bit. But I don't think we've discussed it enough to really have a good answer for you. But hopefully it can also be useful for container use cases like Kata containers. If you have any like ideas, I'd love to discuss those too later. I just don't think we've explored it enough yet.
Sure. Thanks a lot. Thanks.
Yeah, thank you so much for the questions.
Okay, looks like Ram's up.
Yeah. Hey, hi, Carolyn. Thanks for the excellent presentation. So if I understand this right, your paravisor is running in the same address space as that of the guest. In other words, it's running in the same VM. Am I
Yes.
understanding this right? Okay. How does it get deployed? Does it get deployed from the hypervisor, or does it get deployed as part of the images that is running within the VM, maybe as part of the distro images? Like how exactly does the paravisor getting deployed in the VM?
Yes, that's a great question. So, at least in Azure's current implementation, again, this could change in Azure and it could be different for other implementations, but the host, when it launches the VM, the first thing it loads into the VM is actually the paravisor itself. So that is the first thing that loads in the VM, and the host basically has a file that has some instructions and some offsets that tells it how to set it up, if it's TDX, if it's SMP, etc. And once the pairvisor loads, that then hands over control to the virtual firmware. So for example, like the virtual UFI, which then transfers control to the guest OS. So as far as like the boot process, it looks very similar to a normal VM, with the exception of like now having the pairvisor be the first thing that actually runs in the guest VM. And that gets loaded from the host today. So basically, the host just has a copy of that, of the OpenHCL, and it launches that.
Right.
But
So
that could change in the future.
So it's essentially in a QEMU kind of an environment, in a KVM,
Mhm.
QEMU, it's like deployed the same way as UEFI is getting deployed in the guest,
Yes,
right? So
because
it's
I
one
think
of the,
they're both virtual firmware. Like you can view the pairvisors as virtual firmware for the VM.
okay, sounds good. Thank you.
Yeah, thank you.
Okay, I've got two quick questions, maybe quick questions, I'm not sure. So you said that this will help a mostly unenlightened guest, and so I'm kind of curious what remains that must be enlightened for the guest to work. And then sort of a complementary question is, what wouldn't you get by using OpenHCL with an unenlightened guest that you would get with a fully enlightened guest?
I'll try to answer the first question, and then I think I didn't quite understand the second. But the first one is we certainly didn't want to require the guest, if it's supposed to be, minimally enlightened, to have like significant changes, and certainly not kernel changes. Those would actually be, I think, more extensive, especially in Windows with the memory manager, to know how to deal with private versus shared memory. So we only modified the pair virtualized device drivers. So like the networking device driver, the storage device driver, it's the ones for Hyper-V. And this was done for both Linux and Windows. And then we essentially backported that to like some older versions, which was, again, like less challenging because it was only drivers and it was a relatively small set of changes. But I mean, I could certainly provide, I think, maybe like the full list of changes and components that were altered, but it was very, very small. So that's why I say like minimally enlightened. In theory, the pairvisor could actually do the bounce buffering on behalf of the guest in the future. So that alignment in the drivers is, of course, the bounce buffering and knowing how to deal with private versus shared memory. And so in theory, again, the pairvisor could do that. That would have some performance penalty, which needs to be explored further to see if this is interesting to do. We've definitely done some POCs internally, but that's why I say like there's nothing stopping the pairvisor from supporting any guest, because it could technically do everything on behalf of the guest, including what those device drivers do. Can you repeat the second question, Dan?
You know what? I will defer that so that I can give Catherine some airtime here, because Catherine hasn't had a chance to ask a question yet.
Thank you, Dan. Great talk, great work. Very excited about it. I was wondering, what's the overhead that you have observed for running? Thank you.
Yes, no, that's a great question. I don't have the numbers with me handy here. I don't know that we've actually shared numbers externally, but I think if it's interesting, we certainly could. We've definitely made improvements between the first version of our pairvisor and this OpenHCL pairvisor in terms of performance. I know this is not the best answer to your question, but I would claim that the performance overhead is smaller than you would expect, partly because of us using async Rust. But I know that's not a really clear answer because it's not numbers. I think numbers would be interesting, and certainly also comparing this to fully inline guests would be interesting. But yeah, I don't know that there's numbers out there today, and I don't know what numbers we could share, but it's something I can look into it and follow up on.
Thank you. Yeah, we're very interested in this. Yes, would love to follow up with you. Thank you.
Thank you for the question.
Okay, and I think
we're
and I think we're down to the last minute or so here. So I think we'll wrap things up here. It sounds like everybody's going to be excited to see this code once it becomes properly open sourced, and you're certainly welcome and encouraged to come back when that is, and we can have maybe a deeper dive or talk about the governance of that code.
That sounds awesome. Thank you, Dan.
All right, well, thank you everybody for your time today. Next week, I think we've got David Kaplan up on the agenda to talk about other things that happened at Linux Plumbers. And we'll need to follow up with David offline to make sure he's aware of that, and look for Rion's help with that. And other than that, I think we are all set for today.
Thanks, everyone. Thanks, Dan.
Thanks, everybody.
Thanks, Caroline. Great talk. And I'm biased,
Thank you, guys.
but I still think it was a great
Thank you
talk.
so much, everyone.
It was.
Yeah,
Thank you.
thank you so
Bye.
much, everyone, and I'll see you next time. Bye.